Welcome to this example. Let's find out what is asked in this example. Suppose you spin two spinners shown below. Let the random variable t represent the sum of the outcomes on the two spinners. Construct the probability distribution for the experiment. When you look at these two spinners, you can see that the sections are not uniformly divided. Like here in the first spinner, this one takes 50% of this spinner. 3 takes just the little section, or I can say 3 takes one part of the spinner, this 7 takes 2 parts of the spinner, and this 1 takes 3 parts of the spinner. Because if we try to divide this spinner equally, then it will look something like this, like that. So you can see 7 occupies 2 parts, and then this 1 occupies 3 parts. So technically here is 1, here is 1, here is 1. So 1 is here, here, and here, and then 7 is here and here. So now we have a fair spinner by doing that. So if we want to do the same thing here, you can see here is 1. 1 part is occupied by 1. 2 parts is occupied by 3. So this 3 is here and also here. So if we extend that on the other side, you'll see that the 7 is on 3 parts. So in the second spinner, 7 occupies 3 parts, 3 occupies 2 parts, and 1 occupies 1 part. Whereas in the first one, 1 occupies 3 parts, 3 occupies 1 part, and 7 occupies 2 parts. So if we spin this, the probability is on the first, the possible outcomes are 1, 1, 1, 3, 7, 7. So if I write that on the first, we may get 1, 1, 1, then 3, then 7, 7. So these are the possible outcomes on the or from the first spinner. And if we look at the second spinner, we have the similar situation. We have only 1, 1, 1. Then we have 2 3s. So 3, 3. And then we have 3 7, 7, 7, and 7. Now, what we are looking for is when we roll or when we spin this spinner, we are looking for the sum on the two spinner. So we are looking for the sum. So let's find the sum. If we get 1 on the first and 1 on the second, that will be 2. 1 on the first and 1 on the second, 2. 1 on the first, 1 on the second, 2. So 2, 2. 1 on the first, 3 on the second, that will be 4. 1 on the first and 7 on the second, 8. 1 on the first, 7 on the second, 8. Similarly, 3 on the 1, 3 on the first and 1 on the second, 4. Now we can continue and complete this table. So here is the complete table. You can see that the possible sum that we have is 2, 4, 6, 8, and 8, 10, and 14. So we have different sum, and that is your random variable, because let t be the random variable, which is the sum. Okay, sum of the outcomes. So in the probability distribution, we'll have the t, and this random variable is 2, 4, 6, 8, 10, and 14, because these are the sum. Now we need pt, that is probability of each of them, because in order to construct the probability distribution, we need the random variable and the corresponding probability. So here we are completing that table. Now if you look at the table and count, you can see you have 1, 2, 3, 4, 5, 6 on this side, 6 on this side. So we have 36 possibilities. And out of 36, if you count how many 2's are there, we have 3 of them. So 3 over 36 or 1 over 12. That is the probability. If you count how many 4's are here, 1, 2, 3, 4, 5, 6, 7. So 7 over 36. That is already the reduced fraction. Now if you count 6, you'll see 6 here and here. You have 2 6. So 2 out of 36 or 1 over 18. 1 over 18. And then next one is 8. If you count 8, you'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 8 out of 36. Now let's count 10. We have 1, 2, 3, 4, 5, 6, 7, 10. So 7 out of 36. And then if we count 14, here they are 1, 2, 3, 4, 5, 6. 6 out of 36 or 1 over 6. So this is the probability distribution, okay, that we obtain for the random variable t, which is the sum of the numbers we obtain when we spin these two spinners. Okay, that is the end of this video.